Now let us do question number 14th one. Let L be the set of all lines in xy plane and R with the relation in L defined as R equal to collection of all order pair L1 L2 such that L1 is parallel to L2. Prove that R is an equivalence relation. Find the set of all the lines related to the line y equal to 2x plus 4. Now we know that every line is parallel to itself, so that is what we'll write. Since every line is parallel to itself, therefore suppose there is line L1, therefore L1 belongs to xy plane will imply that L1 is parallel to L1, and this will further give us, this will implies L1 is related to L1, therefore we can say that R is reflexive. So we have got R as reflexive. Now let us check whether R is symmetric or not. So second one of this, second condition for equivalence relation, that is R should be symmetric. So let L1 L2 belongs to R. So L1 L2 belongs to R. This will give us that implies that L1 is parallel to L2. So but we know that if L1 is parallel to L2, this will give us L2 is parallel to L1. Therefore we can say that L2 L1 belongs to, the order pair L2 L1 belongs to R, and therefore we can say that R is symmetric. So we have also got R as symmetric. Now let us check whether R is transitive or not. So third part of this, let L1 L2, say let L1 L2 belongs to R. So therefore we will get L1 is parallel to L2. Say let this be first one, and suppose L2 L3 belongs to R. So this will give us therefore L2 is parallel to L3, and this will be second one. And we know that here if we see in first and second, L2 is parallel to L1, L2 is parallel to L3, and we know that if two lines are parallel to the same line, they are parallel to each other. Therefore from 1 and 2, therefore from 1 and 2, from 1 and 2, from 1 and 2, we can say that from 1 and 2, from 1 and 2, L1 is parallel to L3, because, so this will write here, because we know that because if two lines are parallel to the same line, if two lines are parallel to the same line, if two lines are parallel to the same line, are parallel to the same line in a plane, are parallel to the same line in a plane, then they are parallel to each other, then they are parallel to each other, parallel to each other. So therefore we can say that R is transitive, therefore R is transitive. So this was our third part. Let us visit back here. First part we have got R as reflexive, second part we have got R as symmetric, and the third part we have got R as transitive. So that is what we will write. Therefore from 1, 2 and 3, therefore from 1, 2 and 3, what we can say that R is reflexive, and also it is symmetric. R is reflexive, symmetric, and also it is transitive and transitive. So therefore we can say that therefore R is an equivalence relation. R is an equivalence relation, because we know that if a relation is reflexive, symmetry and transitive, then it is known as equivalence relation. Now let's do the second part. Find the set of all the lines lead to the line y equal to 2x plus 4. And what is the relation here? Two lines are related only if the lines are parallel. So we know that if two lines are parallel to each other, they have the same slope. So only they differ by the constant. So that is what we'll write here. Uh, we know that if two lines are parallel to each other, we know that if two lines are parallel to each other, they have the same slope. They have the same slope, same slope, but they may differ in the constant. But they may differ in the constant. But they may differ. But they may differ in the constant. Constant C. That is, uh, suppose line L is there. Line L is here. Y equal to 2x plus 4. And if suppose say L1 belongs to R. So if L1 belongs to R, then we'll have L is parallel to L1. Therefore, L1 will be y equal to 2x plus c, where c is an arbitrary constant, where c is an arbitrary constant, arbitrary constant. So therefore, the required set will be, therefore required set is equal to, required set equal to, let this be L1. Required set will be, say A1 equal to collection of all L1 such that L1 is the set y equal to 2x plus c, where c is an arbitrary constant, where c is an arbitrary constant, arbitrary constant. That means uh, this value of c we can take any, and taking it fixed, we will be getting the line as y equal to 2x plus c, because slope is same whenever two lines are parallel. So this is the solution of given question. Question number 15. Let R be the relation in the set 1, 2, 3, 4 given by the relation R equal to order pair 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3, 3, 2. Choose the correct answer. So here let us see whether R is reflexive or not. So here set A equal to, here A is equal to 1, 2, 3, 4, and the relation R is given as to us as order pair 1, 2, then we are having 2, 2, and we have 1, 1, then we have 4, 4, then we have 1, 3, then we have 3, 3, then we have 3, 2. So in total we have 7 elements here. Now we can see that in this one, here there are the elements of the type 1, 1 is there, then we have 2, 2, then we have 3, 3, also we have 4, 4. We can say that R is reflexive since 1, 1, 2, 2, 3, 3, 4, 4 belongs to R. So therefore R is reflexive. Now also we can see that the reverse of 1, 2 will be 2, 1. That is not here. Also the reverse of 1, 3 is 3, 1. That is not present. and the reverse of 3 2, that is 2 3, that is not present. So we can say that is not symmetric. Since 1 2 belongs to R, 1 2 belongs to R, but 2 1 does not belongs to R. Similarly, we can see that 1 3 belongs to R, 1 3 belongs to R, but 3 1 does not belongs to R. And we have this, so 3 2. 3 2 belongs to R, but 2 3 does not belongs to R. Therefore, we can say that R is not symmetric. R is not symmetric. Now for this one, let us check whether R is transitive or not. For that, there is no need to consider the elements of the type 1 1, 2 2, 3 3, 4 4, because they do not contradict that the relation is transitive. So we have to check only for other elements. Now let us check for this one. Uh, so 1 2, and in that also we'll check the elements of the type x y y z. That is the second element of one order pair, and the first element of second order pair should be the same. So such element is here, we can see is 1 2 is for 1 2 and 2 2, there is a tool. There is no need to check it out because it will be 1 2 only. So here we can see here this one, 1 3 order pair 1 3 and 3 2. If you take, then combining them we must get 1 2. 1 2 is there, so that means R is transitive. Here 1 3 belongs to R and 3 2 belongs to R. Also 1 2 order pair 1 2 belongs to R. And also in other order pairs, the concept of transitivity is not is not rejected. Therefore, we can say that R is transitive. So let us write here further. Here xy belongs to R, yz belongs to R. That gives us xz belongs to R. Therefore, R is transitive. R is transitive. So what we have got, R, therefore R is reflexive, R is reflexive and transitive, but not symmetric. R is reflexive and transitive, but not symmetric, but not symmetric. So therefore correct option is, therefore correct option will be, correct option is, what is the correct option here? First one is R is reflexive symmetric but not transitive. It is transitive. R is reflexive and transitive but not symmetric. So B will be the correct answer. So correct option is B. Question number 16. Let R be the relation in the set and given by R equal to collection of all order pair AB such that A equal to B minus 2. B is greater than 6, and we have to select the correct answer. So here R equal to collection of all order pair AB such that A equal to B minus 2 and B is greater than 6. So here, so if AB belongs to, if AB belongs to R, then what we should have? This implies that B minus A is equal to 2, and also B must be greater than 6. So clearly in this case, here we can see that option A is not satisfied, because in option A, B, that is the second element, is 4 and it should be greater than 6, and so only option will be we have to check is B, C and D. Also, because in B, C and D the second element is more than 6, but one more condition we have to check, that is here, that is B minus A should be equal to 2. So the difference of the second element in the first element should be 2. Here we can see that 8 minus 3 will give us 5, and in the fourth one 7 minus 8 is equal to minus 1. We have to find second element minus first element, and in the third option, that is C, you can see that B is greater than 6, because 8 is greater than 6. Also the difference of 8 and 6 is 2, so the correct option will be C. So now that is what we can say here. Only option C, only option C, only option C satisfies the required condition, satisfies the required condition, required condition, because uh, because in order because for the order pair 6 8, for the order pair 6 8, 8 is greater than 6 also, that is B equal to 8 is greater than 6 also, and B minus A, that is equal to 8 minus 6 equal to 2. Therefore we can say that the correct option is the option number C. Therefore we can say that the element 6 8 belongs to R. Therefore order pair 6 8 belongs to R. Therefore correct option will be option number C. Therefore correct option is the option number C. So this is the answer of 16th one.